Hi everyone, my name is Nardas Mautik. Um, Welcome to my channel. So this channel is basically dedicated to um, students taking H2 physics in Singapore. So this channel is basically me tutoring. It's a tutoring physics tutoring channel where I'll be teaching all H2 physics concepts, topics, and concepts while also going through test papers. So if this channel is geared more towards Singapore A levels, but if you're from other countries taking other exams, then don't worry because the topics that I'll be going through will be similar to the topics appearing in international other countries exams, etc. Yep. So okay, so a bit about myself. Um, um, I am currently studying in NTU, doing applied physics. So NTU is basically a university in Singapore, also known as Nanyang Technological University. Um, yep. So I also have an A-level background. I took H2 physics, H2 chemistry, and H2 maths at A levels, and I got three distinctions for them. Um, okay, more precisely, I got three Bs. But I but yeah. So it is not the best, but I feel like I am qualified to teach um, physics to a certain degree. So if you feel like I'm not qualified enough, then um, yeah, it is okay. Yep. Okay, so first we'll be going over the topics that I'll be covering in the first theme. So this, okay, sorry, let me share my screen. Okay, so I hope you can see my screen. So the first few topics I'll be going through is mechanics. Um, so these are the topics: kinematics, work, energy, and power; collision, circular motion; gravitational fields; oscillations; and sorry, I repeated this. Um, yep. So these are the six topics I'll be going through, and so let's first start with kinematics. That's what I will be going through today. And also, as always, if you like the content that I'm putting through and you feel like it's helpful, please feel free to like, comment, or even subscribe to my channel. It will really help support me, and it will give me the motivation to make more videos like this to help other physics students. Thank you. Okay, so let me go through kinematics first. Just okay. Okay. So first, for kinematics, we need to understand what is kinematics. Kinematics is basically the study of objects in motion. So there are mainly two types of motion. One is projectile motion. So let's say you have a flat field, flat ground like this. You have an you have a person. Sorry, I can't draw this well. I'm using a mouse actually, guys. So Okay, so yep. Okay, so this is basically projectile motion. So imagine a person kicking a ball in the air. The ball follows this path and lands on the ground. So this is projectile motion. Sorry. Okay, let me just insert this. Yep. So this is projectile motion. Another type of motion could be linear motion. So imagine a car moving on flat ground. Okay. Yep. So but regardless of what type of motion it is, there are basically four formulas that talks about how objects under motion um, how that talks about how objects um, move um, under any type of motion. So the four formulas are. Let me just write it here. I will go through all the terms and the formulas, so don't worry about it. Sorry, I hope you can see this. Sorry, I'll just maximize this. Hmm. And there is a fourth formula. Let me just think about it. Oh yeah, sorry. It is S equals to V plus V naught by sure V plus U by T by 2T. I miss right there. Okay, so I'll be going through what these are the four formulas that any object that is moving under constant acceleration will abide by. So let's start with what these terms mean. So U is basically initial velocity. V is final velocity. A is sorry, I don't know how to. How do you? A is constant acceleration. Okay, and the keyword here that we need to understand is that it is constant. It is constant acceleration. If the acceleration is changing, then you cannot use these four equations. These four equations don't work when acceleration is not constant. Then S is basically displacement. Right, okay, cool. So please write down these formulas on your formula sheet because um, we will be yeah, we'll be using these formulas for the whole of this chapter. So any question that comes up, these are the four formulas that we use. That's it. Okay, so let me just go to a new page. Okay, so first off, we'll talk about 1D projectile motion. So one, in other words, let's say you have a ball that you throw up and it comes back down. That is 1D projectile motion. So you throw it up and you just throw it up and it comes back right down. Um, so questions. Okay, let's just do a question and you'll see how um, these formulas that I've written down here, how these formulas would would work in answering questions of 1D projectile motion. Okay, wait, let me just. Okay, we will be going through these kind of questions at some point, but for now, I'm just looking at 1D projectile motion. Okay, never mind. I'll just make a question up myself. So let's say you have a flat ground, you have a ball. Um, the ball is thrown up at let's say 20 meters, 20 meters per second, 20 meters per second. Um, and you want to find out how high this ball would go. Sorry, my drawing is a bit bad. Yep. So you want to find out how high this ball would go. So how do you do that? Simple. So we have to use one of these equations. How we do it is we look at so we know that the initial velocity of this ball is 20 meters per second, and the final velocity of the ball is basically when the ball is at the top is 0 meters per second. So and we know what is a. A is basically negative 9.81. So a is which is the acceleration is basically let me just so a is basically minus 9.81 meters per second square. Is equal to g. The acceleration is basically equals to the gravitational field acceleration of Earth. So this ball is basically experiencing a downward acceleration of 9.81 meters per second square throughout its whole journey. So as it goes up and as it comes down. Um, and this acceleration is constant. So we can use one of the formulas given here. So which formula do we use? If you want to use any one of these formulas, we have to make sure that that all we know all of the terms except one, and we only have one unknown. So in this case, we know what is v. V is the final velocity, which is 0. We know what is u, which is 20 meters per second, and we know what is a. And we want to find out what is s. So what we can use this equation right here. V square equals u square plus 2as. So wait, we'll just use that. So use v square equals u square plus 2as, where v equals to 0, u equals to 20, a equals to minus 9.81. Okay, so and also, sorry, I forgot to mention this, but basically, when we talk about these terms, we need to indicate its direction as well. So okay, so we're taking upwards as positive. So acceleration is directed. So A is basically pointing downwards towards the ground. So that is why it is negative 9.81 and not positive 9.81. Whereas V and U are V0, so that's fine, but U is pointing upwards. The velocity of this ball is shown, the ball is shown upwards. The velocity of the ball is pointing up, so it is positive 20 meters per second. And so, yep, so these are the terms. So we have to find S, which is a displacement. This displacement is basically how far this ball moves up and reaches the top. So we sub in the formula, we sub in these values, we sub in these values into this equation, and we find out what is S. So 0 square equals to 20 square plus 2 minus 9.81. Actually, you know what? I think I'm just going to simplify it. I'm just going to make it 10. But please, actually, never mind. It's fine. I'll just keep it as 9.8. No, wait, sorry. I make it 10. Um, for simplification. Yep. So, okay, we'll use A as 10. But in your exams, please make sure A is 9.81. Actually, you know what? I think I'm just going to make it. I'm just going to use 9.81. Never mind. It might make it a little bit difficult, but it's fine. You might make the calculation a bit more complex, but it's fine. I just want to make it accurate as possible. So 2 times 9 minus 9.81 times S. So we have 0 equals to 400 minus. Hold on, let me use a calculator. So 2 times minus 9.81 is minus 19.62. So you get minus 19.62 s, and we bring this term to the left. So we have um 19.62 s equals to 400, and s is equals to 400 divided by 19.62. It's about 20.4 meters. I'm rounding it off to one decimal place. Okay, so if I threw a ball at 20 meters per second upwards, it would basically reach a height of about 20.4 meters. Okay, so let's move to another type of projectile motion, which is 2D motion. Right, okay. So what is 2D motion? So instead of say a ball just moving up and down, this time the ball is projected to the right as well. So it basically, sorry, let me just, it moves through the air, and so this ball basically moves to the right and moves up. So it is 2D. It's not just up and down. So how do we solve this kind of thing? Is we have to resolve this velocity into two directions. One is the vertical direction, and one is the horizontal component of the velocity. And then, so I call this V. I call this Vy, and this is Vx. Sorry, I'm gonna just make my x a bit more clear. Okay, there. And this is V. Okay, so if we have a velocity vector, we can resolve it into its vertical component and its horizontal component. And for each component, we basically use the kinematics equations that we see here, and um, we can, using those equations, we can tell things like how far does this ball move before it hits the ground, or what is the height at which, sorry, let me just make my arrow a bit more clearer. What is the height at which this ball moves, or how far does the ball go before it lands on the ground again? Okay, so we'll be doing questions like that. So we'll go to actual questions on projectile motion. Okay, no, this is simple. Okay, so we'll answer this question first. A stone is thrown at an angle of 30 degrees with its initial velocity of 50 meters per second. Calculate the horizontal and vertical components of its velocity. So basically, the question is, I think it'll be better if I can just show you, put the question right here. Sorry, let me just hold on. Okay. So a stone is thrown at an angle of 30 degrees with initial velocity. Calculate the horizontal and vertical components. So basically, if you draw a rough sketch, it looks something like this. Sorry, I just draw. I should draw slightly. So it has 15 meters per second, and this angle is sorry. No, it's just a bit difficult for me because I'm not using a tablet. Sorry, let me just draw it properly. It's 30 degrees, and initial velocity is 15 meters per second. So we want to calculate the vertical component, which is Vy. 'Vy. 'Vy' and the horizontal component, which is Vx. Okay, so how do we do that? Simple. So if you take a vector, as you know, a vector can be resolved into horizontal and vertical components. Like so. So we can just so for the vertical component, it is 15 sine 30 degrees because we're considering the this is a right angle. I'll just draw it. This is a right angle, and this is 30 degrees. So um, the vertical component is basically and this is 15. Yep. The vertical component is basically um, 15 sine 30, which is this one, which is 7.5 meters per second. And the horizontal component is basically 15 cosine 30, which is also, I think, is also 7.5. No, sorry. It's different. It's 13.0 meters per second. Yep. So that would be the first question. There will be this question. So we basically resolve this vector into vertical and horizontal components using trigonometry. That's all. Then we also have. Okay, we'll do a slightly more difficult question. So let's take. Okay. So a football is kicked with a velocity of 20 meters per second at an angle of 60 degrees to the horizontal. Calculate the time of flight before the football hits the ground. So if you draw a quick sketch of it's basically like this. Sorry, I'm just this is the ball. It moves up and it goes this way. So they're asking how long before this ball reaches the ground again. So basically, what is sorry. what is t. So for this, we have to understand that because the ball comes back to the ground again, the total displacement, which is s, is equal to 0. The initial velocity, u, is equal to 20. And in this case, we have to consider the vertical component, which is u uy. What is uy? Which is 20. I'll just type it in actually, sir. I don't want to use this for. Okay. Okay. So uy equals to 20. Let's look at it. This question. 20 sine 60, which is 17.3 meters per second. So we want to use um, this equation. S equals ut plus half at square, and find out what is t. So let's just write it down. So S equals ut plus half. Shit, sorry. Plus half at square. So S is 0. Uy is basically equal to 17.3 t plus half. A is minus 9.81 and t square. So we have to solve for t. So how do we do that? We first factorize out the t. So we get t equal. Sorry, we simplify this one first. So we get um, half times 9.81 is 4.905. 4.905 minus 4.905 t t square plus 17.3 t is equal to 0. We factorize out the t, so we get minus 4.905 t plus 17.3 equals 0. So we get t equals to 0 or minus 4.905 t plus 17.3 equals to 0, which is equal. So then t is equal to 17.3. I'll just, okay, 17 point minus 17.3 divided by minus 4.905. which is 3.53 seconds. This is 3SF. So as you can see, you have two solutions. T equals to 0 and T equals to 3.53. So which answer do we pick? Obviously, we pick the 3.53. T equals to 0 is the case where the ball just starts from the ground. So when the ball is just thrown, it is also at the ground. So that's why t equals 0 is also a solution. But we pick t equals to 3.53 seconds, which is when the ball reaches the ground again. So this is 3.53. This is the answer. I'm just going to bold it. Okay, so let's do one more question and then we'll call it a day for today. Okay, so we're looking at this question. Question 3. So this is like a typical question. A projectile is launched at 25 meters per second at an angle of 45 degrees. Calculate the range of the projectile. So what this is saying is you have a projectile is launched and you want to find out what is this range. It's very simple. So let's just do the question. So we know that you so in this question we use both ux, the vertical and the horizontal component. So first we find out what uu is. Basically, as you can see, it's 25 meters per second. So we have ux, which is 25 sine, what's the angles? 45, I think. Let's check. Yep, 45. 17.7 meters per second. And you have uy equals 25 cosine 45, which is 17.7 as well. Actually, yeah, that's true because sine 45 and cosine 45 is equal. Okay, so first what we have to do is that we have to find out how long the ball takes to go up and come back down. So we're looking at it from two different points of view. One is that the ball is moving up, and the second is that the ball is moving to the right. So we consider the ball moving up and down first. So we find out how long does this ball take to go up and come back down, and we substitute that value for the time into the horizontal horizontal velocity, horizontal movement of the object to find out how far it moves before it hits the ground. So first we find out use uy. Sorry, this is u. This is ux. Sorry, this is ux and this is ui. Sorry, I mixed up the values. Okay, so for vertical motion, find t for ball when object hits ground again. So how do we do that? It's the same as this previous question. We use S equals U t plus half a t square. So in this case, S is 0, U is uy, which is 17.7, t plus 0.5 minus 9.81 t square. So you have for this part, I'm just going to solve it quickly because so it's 4 point minus 4.905 t plus 17.7 equals 0. So we have t is equal t equals to 17.7 divided by 4.905, which is 3.61 seconds. 3.61 seconds. So now we substitute t equals 3.61 seconds into horizontal motion. So S equals to ux t, which is equal to 17.7 times 3.61. We get 63.9. 63.9 meters. 3s vs f. So um so basically the horizontal motion equation comes from the fact that the horizontal distance that this ball travels is the horizontal velocity of the ball of the object, and times by the time that it it is in the air for. So the time times horizontal velocity is the horizontal displacement, horizontal distance it travels, which is what this thing is. S equals ux means. So ux is the horizontal component of velocity. T is the time. The ball is in the air, and with this you get the range or the distance that the ball travels from its initial point, which is 63.9. Okay, so um um please let me know in the comments if you want me to do more questions like these, or if you have any questions for any question type of questions that you want to do. So this will be all for this for this tutorial. So please let me know in the comments if you want me to improve in a certain area of teaching, etc. Or if you have any questions, or if you want me to go through any particular questions, etc. And yeah, um, so stay tuned. I will be back with another topic, and I'll be doing more questions. And yeah, thank you all for watching this video, and please subscribe if you want to support me, and you want me to put up more content like this. All right, thanks.